Okay. So, let's go over to talking. Hey, y'all. Is Holden. I hope you're enjoying your Friday and not working too hard because it's Friday and, yeah, whatever. The man extracts enough value from us. We deserve a break. But that being said, I'm going to work on some open source code. I think it's going to be fantastic. And I've got some new boots on that I don't think I'm flexible enough to show you, but quite a lot. Um, hmm. Maybe another day. Maybe another day. My flexibility needs a little bit of work to be able to check my boots up enough. Ooh, maybe. What do we think? Oh, yeah. Okay. Anyways, whatever. New boots. I'll work on that. And the main thing that we're actually working on today is transpilation. And so we've sort of got things kind of sort of working, which is a good place, right? Like, and you know, um, I think I think yeah, I think it's a good place overall. Um, yeah. Overall, we're in a good place. We're in a good place, and I think we've got this. And so we're gonna party on. And specifically, what we're going to do today is we're going to explore if doing some of the transpilation logic Python side would be easier, essentially, because like trying to manipulate the Python AST in Scala is kind of crazy town, I'll admit. That was maybe not the winningest of winning moves that I've ever made in my life, but that's okay. We all make design decision mistakes. I thought it was going to be a little bit easier, but in retrospect, yeah. And so let's go ahead and get cracking. So first things first, last night after I ended the stream, I did realize that it was failing CI for kind of silly reasons. Specifically, it was failing CI because I hadn't merged master in anytime recently. And so, that's not a great reason to fail CI. There are all kinds of other reasons why we can fail CI. And so we're going to go do that. And this is going to be explore dash transpilation. And so we can see 17 hours ago, merged master in, still failed CI. Let's go take a look. Okay. And so interestingly, this is good. The Scala side tests looked like they worked, but the Python tests looked like they didn't work, and that kind of makes sense because we actually had added a placeholder Python test that we expect to fail. And so this is actually pretty good, I think. Yeah. Okay, cool. So this actually is kind of what I want. I'm pretty stoked. So what are we gonna do? Here we go. And then this is our friend test udf.py. And so actually what we're going to do is insert true. All right. Bit of a hack, but I think that'll be fun. Use assert in. Make sure we grab. Okay. Cool. Next thing that we're going to do after that is we're going to go ahead and so I've got some thoughts. Specifically, well, here. Uh, yeah, let's keep going. So, that's cool. So, right, okay, we're gonna go find Python udf.scala. So, the other thing that we're gonna do, alt expression is type option of type expression. You are going to be equal to none. Pure catalyst expression. And so then what we do, okay, yeah, if the Python side has provided us with an alternative catalyst expression, return it. Otherwise, possible. If neither are possible, return. Okay, seems good enough. Right. Yeah. Okay, let's keep going. So that's pretty reasonable. I think. Now we have to go up a level, I want to say, because we don't directly construct Python UDF, right? And then the other thing here is let's go find Python UDF, and then we're going to go find UDAF. And over here, the pure catalyst. And And then I think these would go into Python func expression. Let's go find Python func expression. Okay. And then I'm gonna move all of this into. Oh, these are all snake case. I gotta switch them over to camel. Okay. Whatever. That's fine. Move the EST conversion magic to the base case into the base class. Start adding a default. Start adding a way for Python to provide the catalyst expert. Okay. And if we go here, probably actually none of these are running SBT. Okay. Build SBT. Cool. And then we're gonna go over here. Let's go find the things that I did. Okay. Convert AST. Oh no. Sorry. Convert AST becomes convert AST. All. Recursive convert Scala. What else did I do in snake case? Okay. Okay. Lambda T, and then body becomes body. Name AST. Okay. Let's send body. Something here with right AST. And Sure. Okay. From node name becomes get filed from AST. Cool. Convert function. Get filed after match in order. File in order. I guess this is maybe more just cleaning up the Scala side than okay. Get parameter list. Oh no, not what I want. Nope, nope. Yeah. Okay. And the body becomes get body. Okay, cool. Okay. Cool. Cool. Okay. Yep, snake case. Scala. Okay, then Python side, what are we gonna do? All right. So then we need to go find. Um, you are constructing user-defined Python function. Okay, there we go. User-defined Python Scala. It's also now going to take a pure catalyst. That's what we call it. Pure catalyst. Expression is type option. Expression which is equal to none. Okay. Pure catalyst. Oh wait, yeah. Save AST. Match. Case null. Wait, these aren't actually options. This is just expression. save your catalyst expr, and then save your catalyst. Expression equals your expression. Okay. Cool. Have your catalyst expression as an option for constructing user-defined Python function. Cool. So that's great. And then what are we going to do? We're going to go over here to our friend. What? Oh. Logging. Okay, user-defined Python function line 95 and 97. That kind of makes sense. Pretty sure these are going to be 95. Yeah. Doot Python UDF. That's. Oh, I guess extends logging? Wait. It's not the one that we want. We want, okay, yeah. Ah, not what I wanted. Come back here. Fantastic. Ah, okay. None, which is equal to none. Fantastic. Okay, and then we'll go. Okay. Ride. Override. Cool. Hmm. Okay, cool. Got it working again. Uh, With style issues, not required overrides. Cool. So now we've got a way to pass in a pure catalyst expression. So let's go find oh, no, let's reload it. AST underscore dumped. Transpiled is P. You return um, okay, we want to return a underscore J. Oh wait, no, I'm looking in the wrong thing. That's why. Uh, do we return a Java object or no? We can return a. Hmm. Okay, so what I'm thinking about here is we could either go whole hog and return the Java object, or we could just return. Just not do that just yet. Uh, yeah. Um, yeah, expert. Okay. Yeah, expert. I don't want to wrap it. I want to register it. Yeah, that's fine. Uh, these are all that, right? Yeah, these all look like the type as described here is of type column. Okay. I probably don't have LSP working. No. Not what I want. Okay. Um, okay, well, okay, yeah. Let's say for now we're gonna give back a column. Um, Figure that out in a little bit. Yeah, we're not converting it to a Java column just yet. So, hmm, this is almost what I want, but not quite right. Um, oh, okay. Let's let's sort of YOLO this a little bit more. Right. So, normal everything else. We'll hack on this a little bit here, but okay. Essentially, the idea. Um, Otherwise, short circuit on nothing to um, Oh, is that a concrete type that we can use? Okay. Um, AST dot module dot body dot assign dot value, and then if is instance signed ASC dot lambda turn signed else turn signed dot okay, go module equals AST dot module um, module body and then get lambda body. That's just going to be lambda dot body. Okay. I don't think we need a static method for that here. So lambda AST is equal to get lambda from AST info lambda body. Okay, if lambda AST is none. Oh, cool. No, this is awesome. Thanks for saying hi, sweet movies. So, and M. Jensen, um, it's a mixture of things. So we're working on a hybrid of Python, Scala, and a little bit of Java, effectively. So this is a project called Apache Spark, and it exposes a Python API. And so the goal here is to try and transpile simple Python UDFs, so user-defined functions. So if someone does like a lambda expression where they're just adding two numbers, if we can transpile that into SQL or SQL-like syntax, it'll be much faster because otherwise we have to copy data around a whole bunch. And people are more likely to write that because we do have sort of this with this pandas API where you express everything with lambda expressions. So yeah. AST.body. We want to get the, anyways, it's then and so then that looks right. It's not an optional list at that point. parameter list and the ASC. Okay, cool. This oh, cool. So the UDFs still need to be incorporated into PySpark, I guess. Yeah. So the UDFs. So there are basic UDFs that sort of like work, right? Like the current UDFs just work out of the box, but we're trying to make them faster, and so that's why we're trying to transpile them over. And so that's broadly speaking the idea here. I don't TBD if this is going to work, but and so I wrote a first pass of it where we did the transpilation sort of in Scala, and that's was kind of rough because we lost all this type information by pushing stuff over the wire. So it got annoying. So I'm hoping that if we do the transpilation in Python and then shove it over the wire to Scala that way, so shove the sort of the SQL expressions over the wire that way, that'll be better. I don't know if that's going to be the case, but we will find out. And so the main thing that we're going to write here is this convert function. Convert function and is going to be type list of stir, and body is of type A. It's actually let's go ast dot ast terms optional of type column, and so then yeah, I like the oh no. I love talking with people. It makes it way more interesting than when I'm doing this alone. Spin off. I want to do okay, so I think match body case left equals left. That makes sense. Let's call equals underscore transpile. It's no, sorry. Convert. Right call convert function right. And then okay, let's only do that. Match case is that the um, um, uh, and so um, value, and then why do you keep doing this? Stupid autocomplete bullshit. Um, uh, tx equals ast.load. And then params. Yeah. Param index name param name note the Python um, okay. At this point, we don't know. We don't know who the children are, essentially, because we construct the user-defined function here, but we're not like called around anything in particular. Let's go take a look. Yeah, because we don't know that until later. Fudgesicles, when we're called. Um, It. Okay. Alexa, stop. Interesting. It. Shit on the stick, as we would say. So, um, we need to do something here that we can't really do super easily. Let's think about it. So we could add a new node type. Um, we could add a new node type. Would that do what we want it to do? Okay. And at this point, we don't know who our children are. Be be. So to do add a special node here that indicates we want child number param index node. Okay. Well, so the other thing is like this does look a lot easier. The thing here though that we've sort of come up against is that we're gonna need to add a new expression or something. Fuck. Having a new expression is like kind of annoying. I don't super want to do that. So we are going to come back to this, I would say, maybe next week. Yeah, let's try and come back to this next week, and we will go from there. This feels like a rabbit hole of indefinite length. Ooh, shit, not what I wanted. That probably changed more than I intended. Okay. Okay, cool. Okay, I'm gonna wrap it up. I'll see y'all next week. Have a great one. Thanks for chatting, Jansen and folks.